Welcome to Chapter 7. It's all about strings this week. And remember, a string is a group of letters and characters, but they don't work like all the other data types. So we're going to work on something called the character class method and work with string objects. So first thing to understand is each string is a class within itself. And we call that a class object. And remember, string is not like the other data types, like if we were talking an integer, int, or a double, or a character, a char. So a string is an entire class object, and it holds an area in memory like all the other data types. When you do compare two strings to each other, just like we do with if statements and with for loops, we're going to use the double equal sign operator again. And it's not really comparing the values, it's really comparing computer memory locations. So we'll talk about that more as we dig in. So let's take a look right here. Let's first don't do it. We said that we are going to use the two equal signs, but not in this same way. You can't just say, let's say we had this name Carmen, and we allow them to input another name. So Carmen, and I'll use my first name, Corinne. So let's say we were comparing these two names. This won't work. So if you said a name is Carmen, is that equal to Corinne? Even though we said we'll use these not in this fashion, because this would be to compare the values, not to compare the memory and location. So even though I just showed you code, this will give you an error. This does not work. So we've already learned that a character holds just one single character value. And remember, we use single quotes. Strings do work with multiple characters, whether there's a space in there or there's not, and we use double quotes if we're assigning them. In a moment, we're going to be using two classes to help us compose the data in a string. It's going to be string builder and string buffer. We also have the character class, and this is when you're comparing, for example, is a character or a string uppercase and or switching it to uppercase. Let me explain the difference. Today, as we go through this, any method that starts with the word is comparing the two. Is it true that the first letter of capital C, Corinne, is a capital letter? So it's testing it, and it returns a Boolean value because it's going to come back as true or false. If you see any methods today that start with the word to, it actually is changing the format. It's not comparing it. So if I put in lowercase Corinne and now said to change it to uppercase, Corinne would be changed in memory to uppercase Corinne, or if I'm just doing that to the first letter. Got it? Let's start off with a very, very simple string class that we've kind of already done before. So here we are in main. We're having slogan 1, slogan 2, and slogan 3 assigned to the string class. And notice our double quotes, I'm loving it, have it your way, finger licking good. Hopefully you know what slogans this goes with. So it would print out famous advertising slogans, and we could put slogan 1 with a little asterisk in between, slogan 2 with a little asterisk set, and slogan 3. So if we run this, as you would expect, it prints just like this. To understand strings, let me first introduce a new term possibly to you. It's the term ASCII. ASCII stands for the American Standard Code for Information Interchange. It just means we needed to tell the computer way back when, 50 years ago, whether a letter was alphabetized before another letter or a number. So they came up with this chart or table. And if you don't see one anywhere, just type in ASCII chart into Bing or Google and you'll find it. It'll look something like this. And here's why this is important to understand. before I show you our first really big coding information here. Look right here. Here's the capital letter A where my mouse is circling. It's assigned to the ASCII code of 65, or the decimal code of 65. And there's even a hexadecimal, which just means base 15. I won't go into that today. But anyway, so the letter A is, to the computer, is seen as the number 65, not numerically, but as far as sorting or order. And capital B is bigger in the alphabet, so it's 66, and we go all the way from A to Z. So that's why when you tell the computer to sort something, it knows that A comes in the alphabet before, let's say, Z does. Now, important to the story, well, what about lowercase letters? Well, they're even smaller. Go figure. Look at A is 90, oh, sorry, larger. A is 97, all the way to Z is 122. So if you were to sort, capital A would definitely come before a lowercase a. So this is lower, gets bigger, gets bigger, gets bigger, gets bigger. And there's some other important pieces. Here's where digits fall in, 0 to 9. The one that's really common is this one. Number 32 is a blank space. If you ever alphabetize, a blank space is lower than all the other items here. And you can even see where semicolons, colons, question marks all fall into play. Let's start off with a really super comparison. Notice right here, I have this compare to, and we're using it in a simple program. I want to show you over here what's happening in memory. When we say string, we're going to call it my string 1. We're going to assign it to A. Now I know what you're thinking. Why aren't we using a character? Because we certainly could, and assign it with single quotes. But I want to show you that a string could be anywhere from one letter to many, many letters, or symbols, or characters, or numbers. And string 2 is B. So right over here in memory, they get assigned to their own area. And now we want to compare my string, or A, compare it to my string B. And what would the computer actually print out here? Now, we'll need to go to this ASCII code, also called Unicode, to kind of know that answer. I mean, you don't have to know all these numbers, but I want you to understand why we get what we do. So here's A and here's B, and clearly 65 is less than 66. And if you remember from the chart we were just on, it says here, if a negative number, if the calling object is less than the argument. So in other words, the first item is less than the argument. So we're going to get a negative number. Let's actually go look at it in a code window, same exact code here. I'm going to hit run, and I get a -1. But important to the story, it is a negative value, but will you always get a -1? So now let me go up and change it to a capital letter C. Now still A is less than C because 65 would be then less than 67. But I think you'll find it interesting what output we get. We get a -2. Still a negative. And yeah, D would be -3. And let me show you something really interesting. Let me put a lowercase a. Now let's go back to the chart. So here is a capital A is 65, a lowercase a is 97. Boy, is that less than. So we're definitely going to get a negative value. But let's see if you're already in your head giving the answer. If you took 97 minus 65, I wonder what you would get. So let me go ahead and run that. We get a -32, and I hope that's what you just did. So if we put a value that's less than the second value, we get any kind of negative value. Let's go the other way now. Let's put in a lowercase b and an uppercase b, and now run it. Now, we now have a number, the character first is a larger value than the second. And if we go to run it, oh, we get 32. If you're wondering why a positive 32, well, we were comparing a 66 to a 98, and that's 32 numbers away. So that's why you get these values. So, but very simply, it would now be easy to make a program that is determining whether it's a positive value, a 0 if they're identical, or a negative value. So let me now take you into larger programs so we can kind of see this in action. So let's start at the beginning. Line 6, our secret password of all times is dog. By the way, not very secure. Doesn't have any characters or any of the things they tell us to do, right? That would be very hard to guess. Line 7, whatever the user guesses the secret word to be will be called guess. We're going to have int to compare. We'll talk about that in a moment. And line 9 is asking them to input a value, and 10 and 11 says try to guess the secret word. It is a 3-letter word. At least they gave us that. And line 12 is assigning whatever they type into the keyboard as input and assigning it to guess. And don't forget, all values input from the keyboard are a string. So in this case, we don't have to convert it to anything. It already is a string for once. Yay. So line 13, this is where everything is going on. Let me just highlight that to call your attention to 13. So it's saying take the word, which is dog, and compare it to whatever they type in. Just for sake of argument, let me say they type in the word cat. You say, well, Corinne, we know what to do when there's one letter. Now there's lots of letters. So what happens here? Truly, what we're looking at is it's going to first compare the D in dog to the C in cat. If they were the same, then they would go to the second letter, third letter, on and so forth, right? But in this case, they're not the same. So we're going to compare the letter D and compare it to the letter C. Now, back to the table here. If we have lowercase d and C, C is clearly before or less than D, 99 and 100. So at least we do know what's happening there. And so when it comes to this line, 14 is a little tough. So let's think, what would compare have been? Well, if the D is less than C, I'll let you have a moment to think that through. Okay, let's see if you had a guess. Let's look back at line 13. So what kind of value will compare be assigned? So word, like we said, was dog, and we're comparing cat. So we're comparing the D, which is later in the alphabet, to the C. So because it's later in the alphabet, we'll get a positive value. And not that we have to know, but to be exact, D is one letter after C. So basically, we'd get a positive 1. Although we don't really need to know that for this program. Let me show you. So let's look at the purpose of line 14. So we think compare is 1. Let's hold that in memory. So let's look at line 14. It says, while their guess equals word, and then we see this little exclamation point. Let me first remind you the exclamation point stands for the term not. So what this line 14 and the loop that we're seeing created from lines 15 to 25 in this loop block is it's only going to go into this loop if they have guessed your word incorrectly. So when the guess does not equal word, basically is what they're saying. So you're going to stay in lines 14 through 25 almost forever until you guess lowercase dog. And really, if you had no other clue, you'd never guess, right? I mean, who knows? So we're going to go into line 14 because we guessed cat, right? So line 16 will say system out print, sorry, the secret word is. And you're like, oh, they're going to tell them the secret word is? No, hold on tight. Let's look at line 17. If compare is less than 0. Now, what we mean by this is that to get a negative number, the first string has to be earlier than the second string. And that would tell you how many letters. So if it was like one letter away, it'd be a -1, -2, -3. I think you get the idea from earlier. That's not our case. We said our compare value was 1 or a positive. So line 17 is not going to be true, so line 18 is not going to happen. So we're going to go to the else. So it's now going to print, sorry, the secret word is later in the alphabet than your word. They didn't have to be on 2 lines, but whatever, they did. Then we're going to say try again. We need to prime the loop again or it won't continue. Well, it would continue, but you would never be able to get out of it. So input next line, we're going to ask them for their guess again, assign it to compare. Compare would compare the two. So now if we put in the word Fred or kept going with different guesses, although that's not 3 letters. So when they finally guess the correct word, it'll say, yes, the secret word was dog. So let's see, I've already started to run it here. It said, it is a secret word. I typed in cat. Sorry, the secret word is later in the alphabet. Let me now go with elf. So I try again, and now it says the secret word is earlier in the alphabet. Trying to go for dog, right? And if I finally do guess dog, yes, the secret word was dog. So what I really want you to catch about this is you probably will never really need to know how many letters away it is, or unless it's a program that asks you for how many letters away is it. It's going to be more, is it a positive value? So you know it's earlier in the alphabet, or a negative value, meaning it's later in the alphabet. Remember that. Now let's kind of back up and talk about the character class. Even though we just mentioned strings, the reason a character class is so important to strings is think of a string as made up as individual characters. So we're going to be able to use some of these when we identify individual characters of the string. And I want to remind you from your reading that methods that begin with the word is are just comparing. They're just deciding, is that true or is that false? It doesn't change anything. Any method that begins with a 2 actually physically changes what's in memory. So if you come across 2 uppercase and you had a lowercase d, it would become an uppercase d. And why is this so important? We see this a lot, let's say with a mailing label. It's proper to have the first name capitalized, but not all the individual letters in it. So we may want to change it. So here are some of the commonly used methods. Here's is uppercase and is lowercase. They're just determining if it is true or false. 2 uppercase actually physically changes it. 2 lowercase physically changes it. Is digit determines if it's 0 through 9. And don't forget, since it starts with an is, it's just going to be a Boolean of true or false. Is it a letter? It's just determining if it's any letter of the alphabet, otherwise false. Is it a letter or digit? It returns true if the argument is a letter or digit, or false otherwise. And is it a white space, a blank space, a tab, a new line, form feed, anything like that? So let's see these in action in a real code. So what we want to determine here is we're going to be able to know all about this character. Everybody look right here, char, HR, is the first letter of my name, a capital C, important to the story. And the first thing it's going to print out is the character is this capital C. Notice the blank space so it doesn't shove everything together. Ooh, we have an is uppercase. And notice something here. Do you notice that uppercase has a capital U and a capital C, where lowercase has a lowercase L and a capital C? So be careful. As you know, Java is a case-sensitive language. So let's look at this first if statement. It's saying if the character, this letter C, HR, is uppercase. So let's look. Is that true or is that false? Well, yeah, it's true. So it's going to print out capital C is uppercase. The if statement was true. It prints it out. Not going to do this else because it's uppercase. Let's come down to our next if statement. If character is lowercase, no, C is not lowercase, so it's not going to do this if statement. It will come down to this else and print capital C is not lowercase. So far, so good. Now, we've got some two lowercase. Now notice, is was just comparing Boolean true or false. But when we get to this line where I'm underlining right now, HR equals character 2 lowercase, this is actually going to physically change it in memory. So HR, which was capital C, now gets switched, and HR is now a lowercase c. Make your hand into a lowercase c so you know where we're at. And now, after 2 lowercase, HR is this lowercase c would print out. Oh, look what's happening here. Back to uppercase. So HR is not just being compared, it's being changed. Back to an uppercase C. Change your hand back to an uppercase big C. And after 2 uppercase, HR is capital C. Now let's see, program's not over, but remember when we leave this line, it is a capital C. So now we're going to compare again. Is it a letter or a digit? Now don't forget it's a capital C right now. Well, that would be true, right? It is, in this case, a letter. So it's going to say capital C is a letter or a digit. Yes. It's not going to do this else. And now it's going to compare, is it a white space? No, it's not a white space because it's a capital C. So this if is false. Is statements always do a Boolean. So it's going to come down here and say HR is, I don't know, that should be an I, is not a white space. So pretty clear of how we do that. So a couple things just to review. A literal string is where you have a string that you assign in double quotes. A string variable is an object of the string class. And don't forget, we have java.lang.string. We've already mentioned this equals method. It compares 2 strings to see they're the same. Don't forget, compare to could also work if it's given the value of 0, but equals method computes a Boolean. And before I show you an example of it, there's also something called equals ignore case. Let's say the secret word was dog. And if you remember from our program earlier, it was lowercase dog. How about if someone put uppercase D-O-G, all in capital letters? If you had this equals ignore case method, it would still see them as equivalent if they were exact same letters, but in uppercase or uppercase versus lowercase. Let me show you one more program here at the end of this particular recording. So I want to compare some strings. We've got the Carmen name here. We're going to input another name. So here we're going to ask for some input. So enter your name, and we're going to call that input another name. So we have a name is Carmen. Another name is whatever they type in. I'll use my name, Corinne. So if a name, in other words, if Carmen equals Corinne, well, it doesn't, it would print out a name does not equal another name. And if they had been, if I had typed in Carmen, it would say Carmen equals Carmen. Now, if I had to have typed Carmen just the same way, capital C, little a, little r, little m, little e, little n. If I would have changed the word equals to this one, equals ignore case, as long as I would have typed in any C, any A, any R, any M, any E, and any N, it would still come back as true. So you have 2 options, equals, and we also have equals ignore case. So it sometimes gives a little more latitude of how people are typing it in. Well, we'll pick up in a second back on the second part.